Hello and welcome. My name is Simon, and I'm your AI host and guide to this annual update on what is new in the SimCenter Mechanical Simulation Software Suite. The SimCenter mechanical software tools help you transform mechanical engineering using efficient simulation modeling processes with accurate and fast simulation solvers covering multiple physics domains. At Siemens, we innovate the technology that enables you to redefine your industry. The enhancements made in the 2412 release are no exception, with key updates across industries and new capabilities that will transform your workflows and processes. Highlights that I will focus on in this presentation include an integrated analysis platform for aerostructures, accelerating axial flux machine and EV powertrain design, shifting gear design left, extending smart virtual sensing, and finally, how SimCenter can make your processes more efficient. Keeping the development and production planning of new products within budget and on schedule is a challenge for any aircraft manufacturer. Aircraft companies are experiencing delays on programs for as much as 5 years, costing manufacturers significant additional engineering hours and hundreds of millions of dollars in cost overruns. Due to the increasing number of new and emerging aircraft manufacturers, there is more pressure to deliver with shorter lead times and at competitive costs. Moreover, increasing material and design complexity drives an increase in structural analysis demand. Knowing that 60% of the non-recurring costs of a commercial aircraft is spent on the structure means that any improvement in the structure analysis process will have a key impact on reducing delays and cost overruns. A typical aircraft process has mainly 5 different disciplines: design, loads, finite element analysis, margin of safety calculation, and aeroelasticity and flutter analysis. But this current approach to the structural analysis process is a disconnected mix of commercial off-the-shelf and specialized in-house development tools. Data doesn't flow easily between these tools, and data traceability is even harder to manage. So in order to reduce development delays and manage the complexity of airframe engineering and certification, aerostructure engineers need a more integrated and efficient process. SimCenter 3D is an ideal solution for aerostructure analysis. It gives you an integrated end-to-end aerostructure analysis solution covering the global process from design through certification. The comprehensive integrated platform includes advanced simulation modeling, solvers, and data management. Together, SimCenter 3D can help you cover all stages of analysis, such as load calculations and filtering, margin of safety analysis, and aeroelastic analysis. At the first stage of the process, and after the initial CAD design is available, structural analysts need to edit the geometry for simulation purposes. However, transforming and preparing the CAD geometry for simulation is a very time-consuming and often manual process, taking up to 20% of the analysis modeling time. But what happens when the design changes? Using today's processes and tools, engineers now typically need to repeat the entire modeling process again from the start. SimCenter 3D can help you simplify the modeling process, starting with seamless integration of the aircraft geometry. Direct geometry editing tools allow you to quickly edit and abstract geometry as necessary for simulation purposes, and your entire simulation model is associated to the base geometry. This means you can rapidly update your simulation model to any future design changes without having to start over. And since aircraft models are made of large assemblies of components, SimCenter has the ability to easily manage FE assemblies, so you can easily swap out components when updates become available. This lets you keep your simulation model in sync with design. The margin of safety calculations performed for structural components are primarily done with analytical method, either from standard aircraft handbooks or from the company. But aircraft can have thousands of load cases, and these need to feed the margin of safety analysis. How can you manage thousands of load cases while maintaining traceability for certification? SimCenter 3D can help you efficiently handle terabytes of load case data for margin of safety analysis. You can attach as many results files as needed, and SimCenter will allow you to easily filter, sort, and visualize subsets of all load cases. You can also define linear combinations of load cases to reduce the total result file size without reducing the design space span. Now you can analyze a larger design space for margin of safety than what was possible before, so you can handle all the heavy-duty sizing work without compromising on the traceability nor the end-to-end integration benefits. Nodal force reports and shear moment diagrams can be essential when conducting structural analysis. However, due to the numerous multi-body segments that make up a wing or fuselage, this can be a time-consuming process. Engineers often create their own scripts to reduce the burden, but this creates another burden of maintaining the scripts. In this release, this is no longer the case, as we introduce a streamlined process to evaluate load paths along an aircraft and enable the comparison of values between models and iterations. This capability lets you preview the cutting planes before creating the nodal force reports and gives you a way to understand load paths that follow rib locations on non-parallel ribs and frame directions. Ultimately, you can now analyze free body loads for non-parallel cutting planes, and when all nodal force reports are created, you can generate a shear moment torque diagram along the wing. Understanding aeroelastic behavior of aircraft, like flutter, is critical to airframe development and certification as well. Poor aeroelastic behavior can lead to loss of control of an aircraft, or worse, catastrophic failure. In this latest release, we have extended SimCenter Nastran's aeroelastic analysis capabilities to the supersonic range. This lets you analyze static and dynamic aeroelasticity and flutter above the speed of sound. The name of the game in electric vehicle development is to increase range by both reducing weight and increasing power density of the battery and powertrain. For this reason, axial flux motors are trending due to their potential to revolutionize the EV market. They offer higher power densities and efficiencies than radial flux motors used in EVs today. Companies like Mercedes-Benz, Ferrari, and Renault are exploring novel axial flux motor designs to create smaller, cheaper, and more efficient EVs. But axial flux motors pose engineering challenges too, such as the need to reduce electromagnetically induced noise and vibrations, manage mechanical stress on the magnets, maintaining a uniform air gap and mechanical alignment, and the need for thermal management. However, current simulation workflows require weeks to simulate these kinds of conditions for axial flux motors. You also have to remember that axial flux motors don't live in a silo, and instead they are connected to a transmission and other components. So engineers need to consider the downstream effects of the electric motor on the powertrain, such as electromagnetic loads on the transmission, along with the resulting structural performance and related noise, vibration, and harshness, or NVH of the entire powertrain, so that your end customers have a desirable driving experience. SimCenter Mechanical Solutions help you to develop your axial flux-based powertrain, from initial design through NVH verification. The integration of SimCenter 3D and SimCenter eMachine Design provides the only enterprise software end-to-end workflow. First, you can rapidly search for the optimum axial flux machine design parameters, and then easily transfer the chosen design into an FEA solution. SimCenter automatically generates the motor geometry, sets up the air regions, creates the mesh, and more. You can then simulate performance for electromagnetics, structures, thermal, NVH, and more, so you can ensure your eMachine meets requirements. Let's start with designing the axial motor itself. SimCenter eMachine Design is a digital laboratory for designing a variety of electric machines, including radial flux and axial flux machines. It combines electromagnetic and thermal simulation into a single solution. By using parameterized templates and modeling capabilities, you can rapidly design, simulate, and iterate on an axial flux motor and meet your requirements. In this latest release, you can now model twin-rotor axial flux topologies with an air-core stator. This type of motor topology enables even higher power densities for lower torque ripple and quieter applications. With SimCenter eMachine Design, in combination with HEADS, you can easily explore as many as 500 motor configurations within 2 hours and select the one that best fits your requirements. On top of that, you can go from motor concept design to detailed simulation within a single day with the new capability to automatically create the axial flux motor geometry and FE model in SimCenter. This will set up an associative FE model to the geometry, and then you can run your first FE simulation within minutes. Then you can simply tweak geometry parameters within SimCenter 3D and rerun your analyses until your design achieves the performance you require. And now that your axial flux motor model is within the SimCenter 3D environment, you can easily begin to evaluate performance of the entire powertrain. For example, you can use the SimCenter 3D Transmission Builder to quickly create your transmission model topology and multibody dynamics simulation model. Then you apply the electromagnetic forces that SimCenter 3D calculated for the motor to your transmission model. This can lead you to do more in-depth analysis of gear design within the transmission, and it also helps you determine vibration performance on the transmission casing. You can then apply vibration results for NVH analysis using vibroacoustic simulation. With SimCenter 3D, you are truly creating a digital twin of your e-powertrain within a single environment that you can leverage to more rapidly evaluate how changes to design will impact multi-attribute performance. Simulation and testing for NVH is currently performed late in the development process, leaving little room for design improvements towards better NVH performance. And any changes you do make at the stage come at a high cost and risk to the development schedule. Gears have a significant influence on the transmission NVH response. However, defining lightweight gear blank designs as a time-consuming and labor-intensive process, which makes it difficult to perform design iterations and what-if studies. The design of low-noise gear trains that also maintain high performance for efficiency, durability, and robustness has been a long-standing goal for gear engineers in the automotive industry. As gear train transmission architectures are becoming more diverse to accommodate various types of new vehicle powertrains, an automated process of designing gear trains to achieve the targeted performances has become of key importance. Since NVH performance is a key differentiator in a very competitive EV landscape, it's important to front-load NVH engineering early in the design cycle. Designing optimal gear geometry was typically a multi-tool error-prone process that took too much time. To further speed up the gear design process, SimCenter 3D introduces a parameterized approach to quickly evaluate the performance of lightweight gear blank designs. This capability reduces the need for time-consuming and labor-intensive processes, making what-if studies with design iterations viable. For example, you can parameterize the gear blanks for weight and quickly evaluate compliance calculations to find the best design for NVH performance. Next, the Gear Design Optimization Framework allows you to optimize gear macro and microgeometry parameters for best NVH performance, while making sure it also meets the target on other performance attributes such as efficiency, strength, and durability. The Gear Design Optimization Framework combines SimCenter 3D motion and HEADS to find global optimum gear designs, considering a large design space. With SimCenter 3D, you can determine the optimal gear macro and microgeometry in terms of key criteria for durability, efficiency, and NVH. The sophisticated optimization algorithm helps you to minimize evaluation time, and by connecting it with SimCenter 3D motion, you can account for system-level deflection and dynamics under multi-torque conditions. You can even easily extend analysis to detailed dynamic and vibroacoustic simulations. To measure performance of a physical product or component, you need to outfit the test subject with a number of sensors, like strain gauges and accelerometers, and ensure you have the data acquisition system channels for those sensors. This can be costly for larger structures. Attaching sensors to the testing specimen takes time, and when the geometry is complex, it might even be impossible to fit a sensor into a critical area you want to measure. So how can you measure these impossible-to-reach locations? Last year, SimCenter 3D introduced the new capability called Smart Virtual Sensing, which performs intelligent data fusion between physical measurements and a reduced-ordered FE model. Information from just a few strain gauges placed on easy-to-access areas of the physical model then feed operational information during the test to the SimCenter 3D Smart Virtual Sensing Solver. Based on data coming from the physical gauges, the Smart Virtual Sensing Solver calculates the operational loads and virtual sensor status at critical locations with high accuracy. So now you can see results at impossible locations that you never would have been able to measure before. By using SimCenter 3D Smart Virtual Sensing, you can create an executable digital twin, or XDT. The XDT is packaged on an edge device via a functional mockup unit, or FMU, so that it can run in variable platforms for real-time testing, condition monitoring, or predictive maintenance. Another advantage with using Smart Virtual Sensing is that you can use it to calculate the operational loads that can then serve as input for further types of analysis, such as for durability, so you can better optimize your designs. This latest release expands on this use case for durability by adding the Smart Virtual Damage Sensor that enables you to discover when your machine will fail. Critical damage often occurs in areas where direct strain measurements are difficult or impossible to obtain. Paired with the SimCenter 3D Durability Solver, the new Smart Virtual Damage Sensor will calculate the product's remaining useful lifetime, cumulated damage history, and damage increment metrics based on strain gauges from accessible locations. This comprehensive method integrates physical measurements, data fusion, and durability analysis, providing you with a practical method to measure damage and assess the remaining useful life. Understanding the motion of a body during operation may not be possible, or is at least difficult when constrained by tight packaging, such as in an engine bay. Intrusive methods, like encoders or camera-based systems, make direct measurement of position and orientation impossible. Now, with SimCenter 3D Smart Virtual Sensing and its new rigid body motion sensor, you can place just a few accelerometers or gyroscopes on more accessible locations to fully understand the position and orientation of the entire body. As I mentioned before, simulation in general is often cited as a bottleneck in the overall development process. This is because analysts need to essentially remodel the part for simulation. This can take up to 80% of an analyst's time and often needs to be repeated to simulate further design changes or variations. SimCenter 3D tightly integrates geometry and multidiscipline simulation to eliminate the simulation bottleneck, as it simplifies workflows between design and engineering. SimCenter 3D helps to break down silos and encourages seamless collaboration among component teams, such as with associated and distributed FEM assembly models. Simulation process improvement is at the core of what SimCenter 3D stands for, and this latest release continues to make your simulation processes more efficient so you can innovate faster. Many of you are probably already familiar with the Assembly FEM capability in SimCenter 3D that lets you efficiently create and manage large FE assembly models by instancing in the various FE component models that will make up the assembly. This works similar to how CAD models are assembled and lets various component teams make updates that are immediately reflected into the full assembly. In this latest release, this assembly framework has been extended to the SIM files that define the loads and boundary conditions for each of these components. We call this Collaborative SIM. Analysts working on the assembly SIM can then pick and choose which LBCs to use from the component SIM files, and it lets component teams more easily share loads and boundary conditions to evaluate at the assembly level. This helps your simulation members work more efficiently as a team. In the realm of simulating the build process for additive manufacturing, creating the model used for the simulation process, particularly the mesh, can take time. This can be especially true for those not familiar with finite element modeling. In this latest release, SimCenter 3D now has the option to use a voxel mesh for performing an advanced simulation, such as a thermomechanical simulation with a flexible build plate. This greatly simplifies the simulation modeling step so you can save time. This also helps less experienced users use the advanced solution without having to manually build a tetrahedral mesh. Additionally, a new non-uniform voxel mesh option helps optimize the model to reduce simulation time. Another advantage of the voxel solution applies to printing for tall parts. The thermomechanical voxel simulation will lead to non-uniform temperatures and strains, which means it predicts cool-down shrinkage, as opposed to standard inherent strain methods. As you can see, the 2412 release includes many new capabilities that can help you transform your engineering simulation processes today, and there are far more enhancements than I can cover here in this session. To get a complete view on what's new in this release, I encourage you to visit Support Center, where you can view the full release notes of the SimCenter mechanical products you're using. Support Center is where you will find downloads to all of the latest software, along with links to the community where you can interact with other SimCenter mechanical product users and experts. It's a great resource to help you get the most value for your unique applications. Support Center also includes technical videos, such as the popular SimCenter TV series that touches on a variety of technical topics in mechanical, CFD, system simulation, and physical testing. If you're new to SimCenter, or even if you're an existing user looking to expand your knowledge, then explore the Siemens Accelerator Academy, where you can find online classes that will introduce you to using the product, as well as classes showing how to use SimCenter Mechanical for specific applications. Another resource to check out is the SimCenter blog site, where you can find content that takes a deeper dive into many of the new capabilities that I just touched upon here. I even suggest adding a bookmark to the blog site to keep up to date with the latest news regarding all things SimCenter. Finally, we want to hear from you, our users. Visit j2.com and leave a review of SimCenter 3D. J2 is a trusted peer review site for industrial software, and your experience with the software can help guide and inform other engineers to choose the right software that works for them. And thank you to everyone who has already left reviews, giving SimCenter 3D an overall rating of 4.3 out of 5 stars and ranking it as the number 2 tool in the CAE and simulation category. With that, I want to thank you for taking the time to watch this video. On behalf of the entire SimCenter mechanical team, it's been a pleasure to bring these highlights to you so that you can continue to transform engineering.